Hi everyone. So the goal of this video is to understand energy and power. So there are so many real world examples of energy and power. And anytime you see like watts, anytime you see anything that requires power, that's something that is related to the power that we're talking about in physics. Like 40 watts, that's a measurement of power. When you look at your microwave, and it has some kind of output of power where it says 1,200 watts, or it says 700 watts. Take a look at your microwave and see how much power does it have. Look at your computers and see how much power does it need. There's so many different appliances, and everything that we rely on in our society kind of relies on energy and power. I even encourage you to watch a video that I'm going to post as a should do assignment about the Industrial Revolution and how that kind of changed the way we live our lives. And it came down to like a few people that knew some physics. All right, so what do I want you to learn, and what am I looking for? So your learning target, I want you to be able to define and calculate power and can explain the power in a real world situation using scientific language and mathematical thinking. So try to break that down to what exactly would you be doing? Well, I want you to be able to define power. If I ask you like what is power, I want you to be able to tell me a definition. I want you to be able to calculate power and give me the correct units, which are watts. And then I want you to be able to write 2 to 3 sentences to explain the power in a real world situation. Maybe can you write a sentence that uses math to show how much power is used and compare it to other things that use power. For example, in that last slide, I showed you a light bulb that uses 40 watts, right? But then I also showed you a microwave that uses about 700 watts. Those are two very different amounts of power. And so I want you to kind of be aware of how much power something might need. That's especially important for your project. You want to tell me how much power and energy does something need in your school. All right, and I want you to be able to use words like power, energy, and kilowatts in your explanation. Kilowatts is a number that you'll see a lot when you look at your project, and kilowatts just means 1,000 watts. And if you really want an A, I want you to be able to explain how are force, work, energy, and power related. So what is power? Power is a rate of energy that's transferred. So it's a rate of energy that's transferred. And power is also a rate at which work is done. So you'll see that energy and work are very much related. So when a person goes up some stairs and they're able to go up some height, and they start from not moving, but then they're going up the stairs and they're moving, they've increased their energy. They've increased their kinetic energy and they've increased their potential energy. So they've increased their energy. And so where did that energy come from? Well, it came from like chemical energy inside their body. Okay. They've also done some work because they've moved. They've used some force to go some distance. Or a power lifter. A power lifter, and we call them power lifters because they are using lots of power. They're able to move something very quickly. So it's all about how quickly can you make this energy, move, or how quickly can you do some work. All right. So what does this really mean? And so one thing I want you to notice is that these definitions have the word rate. So this means that we want to know how much energy was transferred per second, or how much work was done per second. That's a key point about power. And so one way to calculate it is we can just calculate how much work did we do divided by how long did it take us. Or how much did the energy change divided by how long did it take us. And another way to write that with just symbols, so power is work divided by time, or it equals the change in energy divided by time. Remember, this delta symbol means change. All right, but so how do we know the energy, or how do we know the work? Well, work and energy are very similar. In fact, they use the same units. They're called joules, named after James Joule, who was alive around the time of the Industrial Revolution. Came up with some pretty good ideas about heat and energy transfer. So energy can be calculated in many different ways. One or two that you might have already seen in class are kinetic energy is 1/2 times mass times velocity squared, or potential energy is mass times gravity times height, And then work is calculated as force times displacement. When you move something, when you push something and you have made it move, then you have done work. So again, power lifter. In this case, we have a power lifter that lifts with 200 newtons. They lift 200 newtons and they move it 2 meters. Well, we could just multiply these two numbers, this force and this displacement. We multiply those two numbers and we would get the work. And maybe you can kind of see already, if you're good with math in your head, 200 times 2 would be 400. So we would say the work is 400 joules. All right, so this is our calculation, right? So something that we've already seen. This is our equation. And power is measured in watts. And that, again, is named after a scientist who was around the time of the Industrial Revolution named James Watt. You'll notice in physics, oftentimes the units that we use are named after scientists. It comes up very often as we move forward in the physics class. So newtons, joules, watts. You'll see many other examples as we go through physics. All right, so again, these are the examples that I already mentioned. So again, I encourage you to look at other appliances in your house, look at anything else that's electronic, and you'll see some kind of measurement that's related to energy or power. Other units that I want you to be aware of, kilowatts. So kilowatts are just 1,000 watts. Again, this is going to be a measurement that you see very often when you're looking at information for your project and the energy used in a building. They might use kilowatts. They might even use megawatts, which is 1 million watts. Okay, so if you ever see those symbols, I guess I just want you to be aware that that's all it means. It's just a multiplication of watts, either multiplying by 1,000 or multiplying by 1,000,000. All right, and then horsepower. If you know anything about cars, or if you've ever even heard about how much horsepower a car has, right, that's just another measurement of power, and it's equal to 745.7 watts. So you can easily convert from one unit of power to another unit of power. All right, the story behind the word horsepower and where that word came from is kind of cool. Be glad to tell you about it sometime in class if you're interested. All right, so here's an A+ answer. If you were trying to explain to me energy, work, and power, here's what I'd be looking for. Maybe you include a little model, maybe showing me a person actually pushing something with a force and it moving some displacement. And then you might say something like this. Energy is the ability to do work. Work is force times displacement. For example, when a person pushes a box with a force and the box moves, the person has done work. Power is work divided by time. Power is also the transfer of energy divided by time. For the person pushing the box, we can divide their work by how long it took them to move the box. So that would be a really good answer for explaining how these terms are related to each other. So what's next? I'll probably make a video to show you some examples on calculating power, and then I'll probably make another video to show you how to analyze data related to power. I want that to be a really useful video for your project. You might do some research on a school and how much energy it uses, and I want you to know, how do you actually make sense of those numbers. So I'll try to give you some examples in a separate video. That is it for now. Look for these videos in the near future.